Okay, so we're doing unit conversions. And the thing I was showing you last time was that any kind of a unit factor can either be set up one of two ways, right? So I think last time, right? You have 1 foot per 12 inches, or flip it, 12 inches per 1 foot. And the way you want to use the factor then is based off which unit then needs to be canceled out so you can get the unit that you want. So we discussed that a little bit last time. So let me just show you another example here. Let's try this one here. I don't know why it's doing that resizing thing, but excuse me. So we know 340 grams, and we're trying to get to kilograms. All right, so let's write that down here. So we know 340 grams, and our goal is to get to kilograms. So we need a conversion between grams and kilograms. And hopefully by now you know, what does kilo mean? Or 10 to the third. Okay, so my question is, where does the 10 to the third go? On the left with the grams or on the right with the kilograms? Left or right? I've heard both ways. Okay, so the kilo's on the right. So the exponent always has to go on the opposite side. So it has to be 10 to the third grams. Because again, I just said 10 to the third basically means kilo. So now you see, oh, it's kilogram equals kilogram. Does that make sense? But if I would have written it the other way, like this, well, then that would have been like saying gram equals kilogram. Does that make sense? That doesn't make any sense, right? So again, I said it last time, the prefix always has to be on the opposite side from the exponent, right? They will never be next to each other. Never, ever, ever, ever. Okay, so we have 10 to the third grams equals, we'll just put a 1 in here, 1 kilogram. So, and I'm going to use that as a nice little unit conversion factor. So, I'm starting with grams, which means the gram part has to go where? Top or bottom? Has to go on the bottom for it to cancel, right? So I put 10 to the third grams on the bottom and 1 kilogram on top. Okay, so grams cancels now, and we're left with kilograms, which we want. So grab your hopefully scientific calculator. I've asked you now 2 or 3 times to bring. You can practice with it. Make sure we all know where that exponent key is. So 340. So now let me do a little erasing here real quick. Okay, good enough. Okay, so we want to write that, or not write that, we want to enter that into your calculator. All right. We're going to enter that something like this. 340. This 10 to the third is on the bottom. So I told you before, anything on the bottom, hit divided by. So 340 divided by, and I want to divide it by 10 to the third. I showed you last time that little key that says EE or EXP, that already means 10 to the. So you can do EE3. And that's the fastest way to get your answer. Now, some calculators, though, when you use the EE, or again, it could be an EXP key, you might get an error. And the reason you get an error is it wants something in front of this 10 to this. So in that case, if yours says error, we'll try it again, but add a little number 1 in there. Try 1 EE3 or 1 exponent 3. And you should get, what, 0.34? Right, what you got? Okay, so it's a real quick question again. Does everybody know where their EE key is, or their exponent key? Everybody find it? And were you able to make this work doing it this way? No. Okay. Okay. And you tried it both with and without the 1?
Yeah, that's right. 340 divided by.
Guess that won't work. Okay, so try 1 EE. So 340 divided by 1 times 10 to the 3. There you go. Now you got the 10 to the thing. There it goes. Now hit the 3. There you go.
Divided by.
So again, some of you have to use 1 in front of this. Like you two both have to use 1 in front of that. And then it'll say, the EE will throw up, oh, a 1 to the little box there means exponent. Okay, so quick question again. How about the sig figs on this? How many sig figs should the answer have? So the question is, how many sig figs does the first one have? 340. Is that 2 or 3? It's only 2, right? So this has 2 sig figs. How about 1 kilogram equals 10 to the 3rd grams? How about that one? Not 2, it is exact. Why is that one exact? Why does it not have any sig figs? Do you remember why?
That's a kilogram.
It's,
Like a
yeah.
is established.
Yeah, they're both metric to metric, and this one then has been defined to be true, right? So it's not a measurement, it's not an approximation. That one's been defined to be true. So no sig figs for that one. So 2 sig figs, infinite sig figs. So 2 is the fewest, so the answer should have 2 sig figs, and it already does. 0.34 is already 2 sig figs. Right? Okay, let's try another one. Okay, let's look over here. How many seconds are in 14.2 hours? Aha! Okay, so we're going to have to do a couple little conversions here. Let's see what we can do. So, I'm starting with 14.2 hours, and my goal is to get to seconds, right? So, I need a conversion or a series of conversions that will get me from hours all the way to seconds. So you may not know hours to seconds directly. You may not, but I'll pretend that you don't. But you probably know hours into minutes, which is what? 1 hour equals 60 minutes. Okay, so same thing. So here we are, we're setting it up, and I need to get the hours to cancel. So hours are here, so I got to put the hours on the bottom. So put the bottom, how many hours? Oh, 1 hour, and then 60 minutes on top, right? Okay, now I'm in minutes, but I want to be in seconds. Okay? So what's that conversion between minutes and seconds?
60.
Yeah, 1 minute is 60 seconds. Okay, so now you can see I've canceled out hours. I'm left with minutes. So now I got minutes on top, so I need minutes on the bottom to cancel. So I put how many minutes on the bottom? 1 minute again, right? 1 minute on the bottom, and then 60 seconds on the top. So now minutes cancels, and I'm left with what I want, right? I'm left with seconds. Perfect. Okay, well, let's punch that in our calculators too, and then we'll check our sig figs here and everything. So 14.2. So on the top, so times 60 times 60. Of course, the ones you don't have to worry about, because dividing by 1 won't change anything. Okay. So I got 51,120 seconds. So the question is, how many sig figs should we have on that? Okay. So the first one, 14.2, that has 3 sig figs, right? Good. How about 60? Because that one's exact, right? Why is that exact?
It's defined.
That one has been defined to be true. So that, yeah, so because that one has, unlimited, infinite sig figs. How about 60 seconds in a minute? It's been defined, so that one's exact. Good. So if we have 3 exact and exact, well, the fewest is obviously 3 sig figs. So how would I round that off to only 3 sig figs? 51,100. Yeah, that's 3 sig figs. Or an even a little better way, probably, just get rid of those ugly little placeholder zeros. We could write it in scientific notation if we wanted to. 5.11 times 10 to the 4th. Also works. But yeah, either of those is okay. Either of those is okay. So yeah, either 51,000 or 5.11 times 10 to the fourth. Okay. Okay, your turn. So try this one out. How many inches are in 2.7 miles? So try it out, work it out. Putting your pencil to a paper will help you remember it. Okay. Let's talk it over with your neighbor. See what you guys got. Help each other out. Check your sig figs. What do you think?
I need to remember the sig figs. What did you get first? 1.7.
Okay, what'd you get? What do you think? How many inches? 1,700,000. Okay. Anybody else? 171,072. Okay. 170,000. 170,000. Okay. Anybody else? 1.7 times 10 to the fifth. That sounds good too. Okay, let's try it out real quick. So let's set this sucker up, see what we think. Okay, so we're starting with 2.7 miles, and we're trying to get to inches. So first thing, I need a conversion that has miles in it. There's one here given to me. 1 mile equals 5,280 feet. So I'm starting with miles, so I need to have miles on the bottom so it will cancel. It tells me how many miles? Oh, 1 mile is 5,280 feet, right? So miles cancels. Now I'm in feet, so I need a conversion that has feet to put down here. So I look and I see 12 inches equals 1 foot. So 1 foot on the bottom, 12 inches on the top. So now feet cancels, and I'm left with inches. So let's try this out. 2.7 times 5,280 times 12. Yeah, 171,072. Well, that's a lot of sig figs. So let's go back and check our sig figs. So 2.7, that has, of course, 2 sig figs, right? 5,280. Okay, well, that's English to English, feet to miles. So that's going to be exact. Let's put E. 12 inches to 1 foot. That's English to English, so that's exact. So the answer has to have 2. So I round that off, and I get 1.7 is probably the best way, times 10 to the 1, 2, 3, 4, 5 inches. Perfect. Yeah.
If it wasn't English to English, would it be 3 sig figs?
Yeah, exactly. Yeah. Yeah. And I think I have some in here that are that way, so let's just try and do one of those right now. Let's see. Let's skip that one. Here we go. Okay, so try F. Jump down to F. Try F out, talk it over. You got a 38 special revolver. These bullets are actually 0.357 inches in diameter. What is that in millimeters? You should still try it. We should print out a blank one, just do it again, help you to reinforce it, and just use that as a reference. Extra practice is good.
I'm sorry. So would you use the 10 to the negative third for the millimeters to centimeters, or?
Well, you're going to have to figure out actually what do they have in common. So centimeters and millimeters both have meters in common, so you should actually do centimeters to meters, and then do meters to millimeters.
Okay.
The best way. Okay, so we're going to have probably about 3 conversions in this one you should be using, looks like. Okay, well, I'm going to head and start working it out in case you're a little stuck. Let's just look at it here. So we're starting with 0.357 inches. And I want to get to millimeters. So I'm in inches, so I need a conversion that has inches in it. And the one that was given was 1 inch is 2.54 centimeters. So now I'm out of inches and I'm in centimeters. Well, I'm in centimeters, but I want to be in millimeters. So what do both centimeters and millimeters have in common?
10 millimeters.
Meters. Yeah, they're both meters, right? So what you're going to have to do is you're going to turn centimeters into meters and then meters into millimeters. So they have them both in common. So first I need something that goes from centimeters to meters. So what's centi mean? 10 to the negative 2. So will that go on top or on bottom?
Top.
Okay. Top or bottom? I heard both. Okay, I see this. Where's the prefix? Where's the C at? On the bottom. So where's the exponent have to go? Always the opposite. It can never be next to the prefix. So yes, it definitely has to be up here. That's the easiest way to know. But I know to try to explain that. It's always the opposite of wherever the prefix is. Okay, so centimeters cancels. Now I'm in meters, so I need to keep on going here. So I'm in meters, and I want to go to millimeters. So what's milli mean? 10 to the negative 3. Will that go on top or bottom? Where's the milli at? The top. So the exponent has to go on the bottom. They're always opposite, right? So 1 millimeter is 10 to the negative third meter. There we go. So now meters cancels. Okay, so I want you to try this one on your calculator and really try to use that exponent key. So do it like this. 0.357, oh, it's on top, times 2.54. It's on top, times exponent negative 2. Oh, that's on the bottom, divided by exponent negative 3. So try to enter it that way in your calculator, okay? I'll change a different color and I'll write that out, just to make sure. I really want you to be able to practice using that scientific calculator because, like I said before, it's always sucks when you get to a test and you can't use your calculator. EE negative 2 divided by EE negative 3. Or like I said, on Tony's and some people's, you got to put a 1 here on some people's. So if it gives you an error, then try 1 EE negative 2, 1 EE negative 3. Okay, so I'll try it on my calculator. Okay, I got 9.0678. Does that sound right? Okay, so the question is sig figs, of course. How many sig figs is in 0.357? That's 3 sig figs. How many sig figs is in 2.54 centimeters? Okay, I have a question. Is that 3 or is that exact?
Exact.
You tell me.
3 because it's 1 to the.
Yes, that is the only exact English to metric one I said, right? That's the only one that is exact. So this one is exact. Remember I told you right, there's only one English to metric exact connection, and that was one that was defined back in like 1970s. That's the only exact English to metric. So yes, inches are English, centimeters are metric. That's the only exact one. How about 10 to the negative second? Okay, that's metric, so that's definitely exact. How about millimeters to 10 negative third meters? Metric to metric, so that's exact. So the answer has to have how many? 3 is the fewest. So we'll round that off, and we'll get, how would I round that off? 9.07. Right, millimeters. I don't have room, I'll squeeze it down here, I guess. Okay, let's do maybe one more together. Let's look at this one. How many ounces are in 5.22 times 10 to the third? What is DG? Decigrams, right. Decigrams, good. Okay, so try that out. Decigrams. Let's see, so we're starting with 5.22 times 10 to the third decigrams. And I want to get to ounces, so I'm looking here at the conversions I'm given. I'm given pounds to ounces, I'm given pounds to grams, but I'm in decigrams. Okay, well, decigrams to grams, that's one that I can figure out, right? So I can do that one. So to do that, I need to put the decigrams, obviously, on the bottom so it will cancel, right? So you always know immediately what goes down here, because right at the bottom is always whatever you started with all the time. So now I know I need some kind of conversion that has decigrams in it. Well, I want to get closer to ounces, pounds, and grams, so I can do decigrams to grams. Deci means 10 to the what?
-1.
-1. Okay, so will that go On the bottom with the deci or on the top with the gram? Top, right? Opposite of wherever the deci is. So 1 decigram is 10 to the negative 1 grams. Okay, so decigrams cancels. Okay, so now I'm in grams, so I know I need a conversion that has grams down here. Oh, and there was one that was given to me that had grams right here. 1 pound is 454 grams, so I'll do that one. I'll put 1 pound is 454 grams. So now my grams cancels. I'm going to keep going. Now I'm in pounds here, so I know then the next conversion has to have pounds on the bottom, right? So I need something that has pounds in it. Oh, right here. 1 pound is 16 ounces. So 1 pound is 16 ounces. Now pounds cancels. Okay, so I punch it all in here. Let's see. So 5.22 exponent key 3. Please practice using that exponent key. Don't type it in times 1, 0 to the 3. That will bite you in the ass eventually. The exponent key will save you. Use the exponent key. So try it. 5.22 exponent 3 times exponent negative 1 divided by 454. It's on the bottom, right? So you divide by what is on the bottom, and then you times by 16. Okay, let me just write that out because I think that's helpful. Again, I've said several times, whatever's on the top you multiply, whatever's on the bottom you divide by. So the way I enter that in is 5.22, and then I hit my exponent key, 3. Oh, then I see 10 to the negative 1 on the top. That's on the top, so I'm going to multiply. So I'm going to multiply by exponent negative 1. What's next? Oh, 454, but it's on the bottom. So I'm going to divide by 454. What's next? Oh, 16, that's on the top. It's on the top, so I multiply. And that's how I would enter it, something like that. And then I got 18.396, yada yada, is that what you got? Okay, so 18.396 and a whole bunch of digits going on there. So how many sig figs should it be? So let's look here. So 5.22 times 10 to the third, how many sig figs is that? That's definitely 3, right? So yeah. So yes. So yeah, the first one then is definitely some kind of a measurement. How about 10 to the negative 1? That's been defined, right? That's metric to metric. That has been defined. So that is exact. And the 1 we know is always exact too. The 1 is always exact. How about this one? 1 pound equals 454 grams. Well, that's pounds are English, grams are metric. So that one's English to metric. So how many sig figs in that? Okay, this one is 3 sig figs down here, right? That 454, that's 3 sig figs. That's not exact, right? Because English to metric. How about 16 ounces to a pound? Those are both English, right? English to English, so that one is exact. Yes, that's been defined. So 3 exact, 3 exact. The fewest is 3, so my answer goes to, what would you make it? 18.4 ounces. Yes, the little 3 was the sig figs there. Sorry, ignore that little 3 there. Is that kind of confusing? Yeah.
So if it's not exact, you take the bigger number to figure out the number of sig figs?
Well, the 1 is always exact, I said. The 1 in any conversion is always exact.
Okay.
So it's whatever the other one is.
Okay.
And if there were 2 numbers, I guess, you just pick the smallest. So if 1 was 3 sig figs, 1 was 4 sig figs, well, still, 3 is the smallest. Right. But the 1 is always exact, we said. Okay, the 1 is always exact in a conversion. Okay. Well, I'm going to skip the last one just for time's sake, and let's move on to our last topic here. We've got just over half an hour here. So let's discuss percentages, parts per million, and parts per billion. So I'm sure you've used percentages before. So yeah, so you probably know that a percent is the part, or whatever you are studying or you're looking at, divided by the total number, right, times 100. So for example, if you wanted to know the percentage of girls in this room, right, you add up the girls over the total number of people times 100, right? The part over the whole times 100. Okay. So that's a percent. So for example, maybe you have a food that's 15% by mass of fat. Okay, well that means then, right, it's 15 grams of fat out of every 100 grams of food. Because a percentage is always out of 100, right? So 15% is 15 out of 100. 5% is 5 out of 100, right? Or whatever it is. It's always out of 100. Well, but also true, though, is you can always have this factor, and you can always flip it, right? You can always say, or that means there's 100 grams of food per 15 grams of fat, right? Right? I was saying before, right? So any one of these factors, you can always flip them the other way, right? Always, always, always. Flip them either way. Okay? That's me. Well, you could also say there's 15 milligrams per 100 milligrams. As long as both units are the same, you're cool, right? Because again, it's by mass. So it's 15 out of 100, whatever your units are. So, or it could be pounds, right? You could have 15 pounds out of every 100 pounds, or 15 tons out of every 100 tons, or 15 kilograms out of every 100 kilograms. But just 15 out of 100, whatever your units are. In our case, it said by mass. It's going to be some mass unit like grams or pounds or kilograms or something. So I said, here we go, pounds, right? 15 pounds of 100 pounds. Does that make sense? Because it's a percentage, right? And percent's always out of 100. Right, so a 90% would be 90 out of 100 points or whatever, right? Or in this case, it could be 90 grams out of 100 grams, or 90 kilograms out of 100 kilograms, or 90 tons out of 100 tons. It's always out of 100, whatever you're measuring in. Okay? So now we have then a new way to write a conversion factor, right? So this percentage can be turned into a whole slew of conversion factors. Okay? So I'll do one with here. So let's say, here's one. It says, this is number 8 on your handout if you got it there. It says the human body is composed of 65.0% oxygen. How many kilograms of oxygen are in a 75 kilogram man? Okay, so 65%, let's think about that. 65.0% oxygen. So that's the same as saying what? What kind of a factor could I draw from 65.0%?
65 over 100.
Or 65.0 over 100. Whatever unit I want to use. So in this case, I'm going to use what unit? Kilograms, it looks like, right? Because give me everything in kilograms. So I'm going to say 65.0 kilograms of what? Oxygen. So I'll just put O, oxygen, over every 100 kilograms of whatever the whole is, right? In our case, the whole is the man or the person or the body or however you want to write it, right? I'll just put man. Okay. Right? That means 65 out of 100, right? Yes. Awesome. Okay. So, I want to take 75 kilograms of man, that's what it is, and I want to turn it into kilograms of oxygen. Well, I have my conversion factor right here. It was given to me. So I know for every 100 kilograms of man, there's 65.0 kilograms of oxygen. So I need kilograms of man to go on the bottom to cancel. And how many kilograms of man? 100. Yes, 100 kilograms of man is 65.0 kilograms of oxygen. Kilograms of man cancels. I'm going to punch that into my calculator. That's what we get. So 75 times 65.0 divided by 100. So I got 48.75. Okay, so let's check our sig figs here. Okay, so 75 kilograms. Is that, what is that, 2 or is that exact?
2.
is 2, right? That was measured, right? Right, it's measured, right? A man's mass is not defined, it has to be measured. So you had to measure his mass, so that's definitely 2. How about 65.0 on the top? That is 3, right? That has to be measured too. But the amount of oxygen in the body has to be measured, so that's 65.0. Now the 100, though, is that measured or is that defined? Yes, that's defined. Why is that defined? Well, yeah, I guess that's true. Right, as far as a whole man, it's always a whole man. But yeah, but it's always 100 for a percentage, right? 100, I mean, right? It's always out of 100 for a percentage. By definition, a percentage is always out of 100. So this will never change, right? This will always be 100. So that one's exact. So I've got 2 sig figs, 3 sig figs, exact. So what's the fewest? 2 sig figs. So I'll round that off and make it, what do you think? 49. And it's actually kilograms of oxygen, right? Right, I was in love with kilograms of oxygen, didn't cancel. Okay, so yeah, so there's 49 kilograms of oxygen in a 75 kilogram man. What that says. Okay, you are giving me the very blank looks. Let's try another one. Okay, let's look at a nice IV solution you might use in a hospital. So an IV typically is about 0.9% sodium chloride. If the total bag contains 1 kilogram of solution, how many grams of sodium chloride are in that solution? Okay, so let's think about what this is telling me. So what does 0.9% mean? 0.9% is same as saying what? 0.9, whatever it is, out of 100, whatever it is, right? So, and it's 0.9 sodium chloride, which you don't know yet what that is, but I'll just tell you it's NaCl, sodium and chlorine, out of 100, and the total thing is the saline, right? So I'll just write solution here. Now the units, again, could be grams, could be kilograms, right? Could be milligrams. As long as they're both the same, it doesn't matter what the units are. Okay, so I'm going to try to start with what? I want to know how many grams of sodium chloride, my goal, are in what? The bag. In the 1 kilogram of solution, right? Can you break down that little word problem there? Okay, so 1 kilogram of solution is where I'm starting. I'm going to go ahead and abbreviate solution the way we typically do in chemistry, SOL''N. So I want to take 1 kilogram of solution, and I want to turn that into grams of sodium chloride. You with me? Okay, and I know that 0.9% relates sodium chloride to solution. So, how can I use that little 0.9% as a conversion factor to help me get from solution into sodium chloride? What could I do? Okay, yes, true. Okay, yes, very true. Actually, then we actually do have 2 ways you could do it. So one person said we could turn this into grams first, and then use this in grams. Or you could use this in kilograms, and then turn that into grams. Either way will work, so I'll show you both ways. How about that? I'll do it both ways. So yes, one way to do it, somebody said, is use the percentage right now and say, oh, well, for every 100 kilograms of solution, there's 0.9 kilograms of sodium chloride. Right, so that's one way to do it. And then kilogram solution cancels. Now I'm in kilogram sodium chloride, but I want to be in what? Grams sodium chloride. So I'm in kilograms, that goes on the bottom, but I want to be in grams. What's kilo mean? 10 to the third, top or bottom? The opposite of the actual kilo thing there, yes. Okay, so now kilograms cancels and I have grams. Okay, so that's one way to do it. So I'll punch that in my calculator and see what I get. 1 times 0.9 divided by 100 times exponent 3. I got 9 grams. Okay, how about sig figs real quick? And I'll show you the other way. So 1 kilogram, well, that's just 1 sig fig. 0.9 is 1 sig fig. 100 is exact. 10 to the third is exact. So 1 is the fewest. So it's going to be 9. Okay, so that's one way to do it. But as I mentioned though, instead what you could have done is you could have done this first and turned kilograms to grams first, and then use the percentage in grams instead of using the percentage in kilograms. So let me show you that real quick. Everybody have that scribbled down before I erase it? Okay, nobody's screaming at me, so I'm going to go ahead. So the other way to do it is, you're right, you could take 1 kilogram of solution, and I could turn kilograms of solution into grams of solution. Same thing. 1 kilogram is 10 to the third grams. And now I could use the percentage to say, oh, well, for every 100 grams of solution, there's 0.9 grams of sodium chloride. And you'll get the exact same answer. You could have done it either way. And you'll still get 9 grams of sodium chloride. With me? Maybe? Barely. Okay. Okay. One more. Let's do one more then. Right? Okay. Again, I'll say it again. Right? This percentage is out of 100, but it's out of 100 whatever you want it to be. It could be out of grams. It could be out of kilograms, milligrams, pounds. Right? Right? Whatever you need it to be out of, it can be out of, as long as both the top and the bottom are the same. So you can't have grams here, kilograms here. That won't work. But both are grams or both are kilograms. Then you're fine. Okay. Let's try the next one then. A dental amalgam used in fillings for teeth contains 44% mercury. It's pretty standard. How many milligrams of mercury are in 75 ounces of amalgam? Okay, let me work this one with you. You guys can help me set it up here. So I'm starting with 75 ounces of amalgam, right? That's my starting point. And I want to go to milligrams of mercury. Okay, so I have lots of choices here again. So I could use that 44% very first thing, or I could use that 44% on down the line. It won't change it mathematically. So I have 75 ounces. I'm going to put amalgam, just so we know. Put amalgam, right? Okay, so we got two ways we could do this. I could turn ounces of amalgam into pounds of amalgam into grams of amalgam, and then use the percentage to turn amalgam into mercury. Or I could do it first, and I could turn ounces of amalgam into ounces of mercury using the percentage, and then go to grams of mercury. Either way will work. So I will ask you, what's your preference? Do you want to do the amalgam all the way down to grams of amalgam, or do you want to do the amalgam first into mercury and then go to grams of mercury? The first one. Okay. Oh, okay. Sorry, I voted. Okay, the first way. So I'll do the ounces of amalgam all the way to grams of amalgam. Is that what you're saying? Okay, let's do that. So ounces of amalgam. So I need something that has ounces in it. I see 1 pound is 16 ounces. So ounces on top, ounces amalgam has to go on bottom. How many ounces? Oh, 16 is a pound of amalgam. Right? Now I'm pounds of amalgam on the top, so I need to have pounds of amalgam on the bottom. So I need a conversion that has pounds in it. I'm trying to get to grams. Oh, 1 pound is 454 grams. So 1 pound on the bottom, 454 grams of amalgam on the top. With me so far? Questions? Okay. Now I'm in grams of amalgam, but I want to be in grams of mercury. So how can I relate amalgam to mercury? Oh, you're right. Milligrams. I'm sorry. You're right. You want to be in milligrams. Okay. So let's keep on going then first, and then we'll do that. So let's turn grams of amalgam into milligrams of amalgam. Thank you. What's milli mean? 10 to the negative third. Will that go on top or bottom? The bottom, right. The opposite of wherever the actual little prefix is. Okay? Oh, okay. Okay, so now I say it. Now I'm in milligrams of amalgam, but I want to be in milligrams of mercury. How can I relate amalgam to mercury? 44%. Yeah. Yeah, so that means there's 44 whatever you want to use of mercury out of every 100 whatever one you want to use of amalgam. And in my case, then, I want to use milligrams. Okay, give me the big scary blank look. So 44, same as saying 44 mercury, which you might know the symbol, hopefully. If not, you still have one more week. Mercury is Hg over 100 amalgam, right? Right? That means 44% out of 100. Again, the units can be whatever I want. Well, I want them to be mercury. I mean, not mercury. Milligrams, sorry. I want them to be milligrams. Right? So, let's say, so for every 100 milligrams of amalgam, how many milligrams of mercury are there? 44. There's 44 out of every 100. Right? See, 44, 44. Okay, so milligrams amalgam, that cancels. I'm left with milligrams of mercury. Okay, let's punch that in our calculator then. See what we get, then we'll check our sig figs. 75. Okay, 16 on the bottom, so I'm going to do divided by 16. Oh, 454 on top, so I'm going to do multiply 454. 10 things are on the bottom, so I'm going to do divided by exponent negative 3. 44 is on top, so times 44. 100 is on the bottom, so divided by 100. And I get 936,375. And that's milligrams of mercury, which again, hopefully you know the symbol for mercury. So let's check our sig figs here. So 75 ounces, that's 2. 1's exact, 16. This is English to English, pounds to ounces. So this whole thing's exact, right? How about 454 grams to 1 pound? That is 3, right? Because the grams is metric, the pounds is English. So that's 3. Milligrams to grams, that's metric, so that's exact. 44 to 100. Well, the 100 is exact, but the 44 is 2. So 2 exact, 3 exact, 2 exact. The fewest is 2 apparently, so I'm going to round that off and make it. What's a good way to write that? 9.4 times 10 to the 5th sounds even better. Milligrams mercury, which I can't squeeze in there. Now, again, the percentage could have been used very first thing. It would work the exact same way. So let me show you that. I have time? Not really, but I'll show it to you anyway. Show it to you real quick. So it could have been done first thing instead. I could have said it was 75 ounces of amalgam, right? So the first thing I could have done was turned ounces of amalgam into ounces of mercury. And I could have said, oh, how many? 44 out of 100. And I could use the percentage very first thing. Because again, they're both mass, right? As long as they're the same units. And then I could have done everything else the same. 16 ounces, 1 pound, 1 pound, 454 grams, 1 milligram, 10 to the negative 3 grams. Same way, and it still would have given you the same answer. So it doesn't matter which way you do it. Okay, so percentage is always just something out of 100. It could be ounces, could be milligrams, could be tons, could be whatever you want to count out of 100. Okay, so that was percentage, which is basically parts out of 100, right? So now we're going to do parts per million, parts out of a million. So if I said something, for example, is 0.5 parts per million, that means there's 0.5 out of a million. If it was 0.5%, it'd be 0.5 out of 100. 0.5 parts per million is 0.5 out of a million. Okay? If it was, let's say 37 parts per million, that'd be 37 out of a million. Okay? Now, one nice thing though about this is we know this is going to be true as well. Same as also saying milligrams per kilogram. So let me explain why that is. Okay. So let's just look at 0.5 parts per million. That's the same as saying 0.5, let's say, grams out of a million grams, right? 10 to the 6. Just like 0.5% is 0.5 out of 100 grams, right? Did I lose you? It's the same thing, right? Okay, well, why is that the same as saying milligrams per kilograms? Well, if I wanted to go from milligrams to grams, milli means... Okay, well, milligrams to grams, that is a 10 to the third difference. Grams to kilograms, that's another 10 to the third difference. So all together, this is a 10 to the sixth difference. So I'm saying from milligrams to kilograms, there's 1 million milligrams in a kilogram. So this can also be written as 0.5 milligrams out of a kilogram. That's the short, dirty answer. So milligrams and kilograms are 1 million apart. So you can also make this milligrams and kilograms because they're a million apart too. So parts per million is out of a million, or you can just say, like I said, milligrams per kilograms. We'll just go back. Go back. Okay, well, how about parts per billion? Well, same thing, but now it's not out of 100. Now it's not out of a million. Now it's out of a billion. And a billion would be 10 to the 9th. 10 to the 9th. So that's the same as micrograms and kilograms. Because, again, a microgram, there's going to be a million micrograms in a gram, and then 1,000 of those in a kilogram. So altogether, that's a billion difference. There's a billion micrograms in a kilogram. So one common way then you might see 6 parts per billion converted is as 6 micrograms per kilogram. So you could do it 6 grams out of a billion grams, but that's the same as microgram per kilogram because those are a billion apart too. Okay, well, let's try a couple of these with parts per million, parts per billion, see what we can do here. Oh, I don't have one in here. I don't have one in here? Okay, so let's go back then. And let's make one real quick here. Let's make up a quick little problem. Okay, let's say we want to know how many micrograms of lead are in a let's call it, I don't know, 155 kilogram water sample, that is 42 parts per billion lead. Okay, yeah.
So that's milligrams, right?
Micrograms, sorry. That's the little micro symbol supposed to be. A little crazy U with a little tail on it. That's the microgram. Okay, so let's say, for example, you work for you're working for the EPA and you're concerned how much lead is in this water. So you sample a big old pool of water, and the pool of water is 155 kilograms. You want to know, well, how many micrograms of lead are in that? So let's start with what we know, the 155 kilograms of water. Draw a little line here. I want to turn that into micrograms of lead. Well, I know there's 42 parts per billion of lead. So 42 parts per billion, that's the same as 42 micrograms of lead out of every kilogram of water. Part per billion is the same as micrograms out of kilograms, you just said. So I can use that then as my conversion factor and stick it right in there. So let's try that. So 42 micrograms of lead is 1 kilogram of water. So kilograms of water would cancel. I can punch that in my calculator and see what we get here. So 155 times 42. 6,510 micrograms of lead. So let's check our sig figs real quick. How many sig figs are in 155? How many are in 42? 2, so my answer should only have 2. So I'll round that off and I will get 6.5 times 10 to the third micrograms of lead. Or 6,500. But okay, well, there's some more practices on those on the homework, so please try them out. Ask me any questions Thursday if you have questions on the homework, or go to FLS this week. Not next week. Next week, FLS. Yeah, so come to my office if you need to. Email me, ask me Thursday, or go to the tutorial center. Okay, so let's do our last topic here. We got 6 minutes. Density is another way of trying to relate substances. So density, you might know, relates the mass of something to its volume. So in a sense, it's how much matter is there compressed into a certain amount of space. So how much mass is compressed into a certain amount of space. What's the next? Let me go back here. Okay. Oh, crap. Sorry about that. So let's say, for example, I have a block like this, okay? Let's say I have a block of wood. Then I have the exact same size block, but it's iron. Well, they're the exact same size block, have the exact same volume, but obviously the iron would weigh more than the wood. Well, why is that? Well, there's more matter, more mass crammed in that same volume. So the iron has a higher density than the wood does. So again, just the ratio of how much mass is crammed into that piece of wood. So for example, lead, you might know lead. Let me do lead. Right? Lead is commonly thought of as a very heavy metal. Lead is about 18 grams are crammed into 1 cubic centimeter. So that cube was 1 centimeter by 1 centimeter by 1 centimeter. It would weigh about 18 grams. Okay? But so let's say over here that we had water. Well, water, again, same size cube, would only be about 1 gram per cubic centimeter. So this one has 18 times as much mass crammed into that same space. Oh, actually, now that I think about it, it's not 18. It's like 11.7, I think. Now I think about it. Sorry. Anyway, whatever. You get the idea, right? So the lead is much more dense than the water. There's a lot more mass in the exact same volume. Well, then, density is also nice because it allows us to convert between mass and volume. So I could convert 18 grams into centimeters cubed, or centimeters cubed into 18 grams using the density. So let's do a couple of those and we'll be done. Okay, so let's say you have a 0.258 gram sample of HDL. It's one of the measurements for fat, right? The high density lipids, I believe that is. And that has a volume of 0.215 cubic centimeters. What is the density of that in grams per cubic centimeter? So it gives me the mass, it gives me the volume. I want to know the density, which is the mass per volume. Well, pretty much the units tell you exactly, because it tells you, oh, you want the grams divided by the cubic centimeters. So let's take the grams. Let's divide them by the cubic centimeters. And that's pretty much it. That'll give us grams divided by cubic centimeters. So 0.258 divided by 0.215. Okay, so what's the density of these high density fats here? What'd you get? 1.2 grams per cubic centimeter. Okay, but let's check our sig figs real quick. So 0.258, how many sig figs? 0.215, how many sig figs? So our answer should have. So how do I fix that? 1.20, right? We got to add a 0 on that. Make it 3. Yeah. Okay. Okay, got 2 or 3 minutes. Okay, let's go ahead and try another one. So, okay. So I said density, right? So here's some different densities of some things you might find in the human body, if you're any kind of medical career ahead of you, right? So albumin, you can see the mass per volume. Ammonia, the mass per volume. Calcium, the mass per volume. Now again, the units might cancel, but it's always a mass unit over a volume unit. So gram is a mass, right? Microgram, that's a mass. Because all these, right? So so DL, deciliter, that's a volume. Okay, so let's try a couple here. Okay, let's look at number 10. Let's say an airliner travels at 955 kilometers per hour. Okay, so what I'm going to do here is I'm going to figure out, okay, what kind of a conversion factor could I pull out of that? And is that an exact conversion or is that an inexact conversion? So let's look at this one. So what kind of a conversion could I draw out of 955 kilometers per hour? That's the same as saying what? What kind of a conversion could I pull out of that? Do you have any idea?
955 over 1 hour?
Right, so 955 kilometers is the same as 1 hour. Right, so you could write it 955 kilometers per hour, or you could write it 1 hour per 955 kilometers, right? Because it always works the opposite way too. 1 hour per 955 kilometers. Oh, whoops, what did I write here? Be 1H, sorry. Okay, so the question is that an exact conversion or is that inexact? Yes, it's definitely been measured, right? So that's been, right, it was the measured speed of an airliner, right? So that's measured. So that's not exact, so we'll have, how many sig figs would I have? Okay, yes, 3 sig figs. How about over here on the 1? Yeah, the 1's always exact, yes. Okay, how about this one? A capsule contains 500 micrograms of vitamin D12. Okay, so let's write a nice little conversion factor between that. So how could I write that?
$500.
500 micrograms equals what?
1 tablet.
Right, 1 capsule. Okay, so is that exact? No, right? Again, it was measured, right? It was measured out, right? It was measured out into that capsule. So how many sig figs would I have for the 500? That's only 1, because there's no decimal. And the 1 capsule, that's exact. The 1 is always exact. Okay, good. Okay, the densest naturally occurring element is osmium, with a density of 22.59 grams per cubic centimeter. Oh, we're out of time when you get here. So, well, that I could write, 22.59 grams equals a cubic centimeter, right? You with me? So yeah, so lots of things in life can become conversion factors. And this one would have 4 sig figs. This one would be exact, right? Okay, well, I'll see you in lab. Is our lab at 3:30 or 3:40? 3:40. Okay. Okay. So I'll see you at 3:40 then. So make sure you have your pre-lab ready just to tear out and hand in when you get there. And you have your procedure done, and your data table's all written out, ready to go. And I'll check all that stuff first thing.